Welcome, students. Please keep yourself tuned in for the fifth edition of Lead Masterclass. We'll be going live soon in a couple of minutes with Mr. Debapriyay Mukhopadhyay, your instructor for the mental math session today. In the comment box, do tell us how excited you feel about today's masterclass. Mr. Debapriyay will be telling us how to have some fun with maths and how to solve maths problems more quickly. So stay tuned for an exciting session ahead. Thank you. Hello, everyone. Welcome to the fifth edition of Lead Masterclass. This is your host for the day, Himanshu. At Lead, we ensure that our students should not only be equipped with excellent academic education, but also with the skills that help them to succeed in life. Maths can be fun to us and related to real life and are taught in a fun way. To remove the fear of the maths in students, we are presenting today's Lead Masterclass on mental mathematics. Mr. Debapriyay has founded the blog Ganit Charcha, and under the umbrella of Ganit Charcha, he and his team work in popularizing mathematics amongst young school-going students. He has been a corporate professional for the last 20 years and is currently associated with Vihir as a senior product manager, and is working in developing solutions for cyber defense. Sounds interesting, right? Now, kids, without any further delay, let's hear it from Mr. Debapriyay. Mr. Debapriyay, over to you.
Thank you, Himanshu, for this nice introduction. Good afternoon, everyone. So last Sunday session, we had seen that mental maths can be useful in various areas of your life. And I have emphasized on the fact that it's not just applying mental maths on your day-to-day life. It can help you boost your confidence in cracking different competitive exams. It can help you achieve good marks in your day-to-day regular school exercises and examinations. But what is mostly important is being able to practice all these things rigorously. So 25 to 30 number of times each and every skill you should practice in order to be in a position to apply it quickly. Some of you have asked the question also that how can we be a maths champion? So I told and reiterating every time that it's not just only learning the skills. Uh, you have to practice a lot. Every day you should practice mathematics 2 hours a day, and then automatically over a period of time you will see that your confidence on maths, your being able to think about different math concepts and problems, your way of attacking a particular math problems are getting changed over time. It's not just coming to a particular solution of a math problem. It's being able to follow through the why part of it, that why we are executing these steps. If you can address these questions mentally on from your side, then possibly you will see that there are multiple solutions or multiple ways to reach to the solution exist. And when you explore these different ways of looking into the problem or different ways of solving the problem, you will automatically feel the beauty, you will automatically enjoy the subject more. So with that, I'll be getting into today's session. But as I have done last day, I started with a mathemagic. This time also I will start with a mathemagic, but I will only state the steps. There is no slide for this. Mm. The reason being, you should be able to follow through whatever I am saying and then come to the answer, because I'll be asking you the answer at the end of the steps. So let me start. You have to choose a 3-digit number where the digit at the ones place and hundreds place differ by more than one. I repeat, you have to choose any 3-digit number where the digit at the ones place and hundreds place differ by more than one. All of you can uh, take one 3-digit number as an example and can apply this constraint on the number that you have chosen. Uh, by constraint, I mean the digit at ones place and hundred place at least should differ by more than one. So, for example, I could have chosen 486. Uh, 4 is in hundred place and 6 is in ones place. So the difference between 6 and 4 is 2, which is greater than 1. So that is what I wanted to mean. You cannot choose 485. You cannot choose 484. So that's what the constraint is. Now you can choose your own 3-digit number on a paper and then can execute the following steps that I will be stating right away. So I repeat once more, step one. So choose any 3-digit number where the digit at the ones place and hundreds place differ by more than one. Now I come to step two. You have to reverse the digits and subtract the smaller one from the larger one. So by reversing the digits, what I mean, suppose you have chosen the number X, Y, Z. So while you reverse the digits, you will get Z, Y, X. So X, Y, Z by reversing the digits will become Z, Y, X. And one of the numbers will be bigger than the other. So you have to subtract the smaller number from the larger number. So that is what you need to do in step two. I repeat, you have to reverse the digits chosen in step one and subtract the smaller one from the larger one. So after subtraction, you have got another number. After subtraction, you have got another number. Let these number be n1. Now you need to reverse the digits of the number n1 to get another number. So in a similar way, you have to reverse the digits of the number n1. Let these new number be n2. So I call this new number, which I have got by reversing the digits at step 2 as N2. So at step 1, I have got a number called N1. At step 3, I have got a number called N2. Now what I need to do, I need to do N1 plus N2. What I need to do is to add these two numbers, which I have got subsequently at steps 2 and step 3. May I now ask you the answer of this addition? That means what is the result of N1 plus N2? I guess all of you have started with your own 3-digit number at step 1, and you have executed through the steps. So if you have executed through the steps correctly what I have stated, then you should have got a number as a result of N1 plus N2. Can you please let me know what is that number?
Sure. So a lot of students are typing to answer in the comment box. So Piyush Saini says that the number that he got is 755. Then we have Vijay Santi says the number that he got is 190. Sanjay Asati says that 423 is the number that he got. Aradhana Rai says that it's 422 that she got.
So the answer that I have got are all incorrect, because what I am expecting from all of you is the answer 1089, because all of you should have got 1089, and that's the magic.
Yes, so Pramod
So let me
Pawar
go
says
through
that
one simple let me go through a simple example. So let me choose my number as 703. So I have chosen the number 703 at step 1. So the digit at ones place is 3, digit at hundreds place is 7. So the difference between 7 and 3 is 4, which is more than 1. So I'm okay choosing this number 703. Now I have to reverse the digits. So after reversing the digits, I have got 307, because 703, when written in the reverse order, you will get 307. Now you have to subtract the smaller one from the larger one. So I will subtract 307 from 703. So what I have got is 396 after subtraction. So this is my number N1. I told that the number you have got at the end of step 2 after subtraction is N1. So my N1 is 396. Now at step 3, I have to reverse the digits of N1 to get N2. So I reverse the digits of 396 to obtain 693. So I have got 693. 396, the digits are reversed and I got 693. So this is my N2. Now I have to sum N1 and N2 to find out N1 plus N2, and which is obviously 1089, which is 1089. So irrespective of your choice at step 1, if you followed step 1 properly, and if you execute all the steps correctly, then you must have got 1089. You should not be getting any other number. You are bound to get 1089. So I will ask all of you to try this out at your leisure time, and you will see that you are always getting 1089 if you have chosen the digit correctly with the conditions stated at step 1. And you can also try to find out the proof for that. That will be a great exercise for you to do. Now with this, I am going into or getting into the main stream discussion that I have planned for. So mostly I'll be talking about division rules uh, in today's session. So these division rules are really helpful, and they you all need to know that, because they come as handy in different other math problems, particularly when you are required to do factorization, particularly when you are required to do find out prime factorization, and when you are required to find out HCF, when you are required to find out LCM. So you need to find out highest common factor. So obviously you need to find out all the divisors of the numbers involved. When you are required to find out least common multiple, at that time also you are required to find out for first what is the highest common factor, and then you can multiply it with the other individual factors to find out the least common multiple. So in all these areas of mathematics, knowing the rules to check quickly whether a particular number is divisible by the first few basic integers are very helpful. First few basic integers, by first few basic integers, I mean from 2 to 9, because the moment you are done with being able to figure out uh, whether a particular number is divisible by any one of 2, 3, 4, 5, 6, 7, 8, or 9, your number will be a smaller one. So then you can try to figure out whether any divisor or any prime factor which is even more than 11, 13, 17, 19, 27, 23, or 31 or so exists or not. So it's basically to help you speed up in solving certain problems. So let's go over this. So we will first start with the number 2, which is pretty simple. You can very easily guess that. Uh, so if you see that 0, 2, 4, 6, and 8 are present in the ones digit or units digits place, then that means that number is an even number. And that also means that the number is divisible by 2, because any even number is always divisible by 2. Now, what about other numbers? Basically, the whole set of integers can be divided into two classes. The whole set of integers can be, or numbers can be divided into two classes. One is even integers or even numbers, and another is odd numbers or odd integers. There is no even number which is odd. There is no odd number which is even. So basically, that exhausts all of your all the numbers or integers of the number space. So that means any number or any integer has to be either an even number or a odd number. There doesn't exist any other uh, class of numbers if I define in this way. So what about odd numbers? So the units digit or the ones digit of any odd number is either 1, 3, 5, 7, or 9. So if you see any number which is ending with 1, 3, 5, 7, or 9, that means it's an odd number, and that means it is not divisible by 2. Now we will get into the divisibility by 3 and divisibility by 9. So they are mostly related, and they are mostly similar. So a number is divisible by 3 if the sum of its digits is divisible by 3. So what does that mean? So if you take the example 1, 2, 3, 6, so that's a huge number, right? 1236. So 1236, if you are required to find out whether it is divisible by 3 or not, first of all, you have to divide 1236 by 3, and that will take some time. But instead, what this rule says, that you sum all the digits of this number. So there are 4 digits in this number. So one is 1, and then next number is 2. So I sum 1 and 2, that is 3. Then the number at tens place is 3. So I sum it with the previous result. So 3 plus 3 is 6. And then the digit at the ones place is 6. So I sum it with the previous result, which is 6 is 6. So 6 plus 6 is equal to 12. So 1 plus 2 plus 3 plus 6 gives you the value 12, which you can easily check and validate that it is divisible by 3, because 3 fours are 12. So since 12 is divisible by 3, 1236 is also divisible by 3. So that's what this rule says. So you can see that how quickly we can validate whether a particular number is divisible by 3 or not, without even going into any division, division doing. The similar sort of rule applies for divisibility by 9. So only change is you have to check whether the sum of the digits is divisible by 9 or not. In the previous case, you have done sum of the digits and you have checked whether the sum of the digits is divisible by 3 or not. In this case, you will again do the same thing. You will take sum of the digits and then you will check whether the sum of the digits is divisible by 9 or not. So in this case, one example is 585, which you see that without going for a division, I can just simply sum up the digits. So 5 plus 5 plus 8 is equal to 18. So 18 is 9 2 is 18. So it's divisible by 9. So that means 585 is also divisible by 9. Now, let me ask you a simple question. Can you please help me validate whether 2353 is divisible by 3 or not?
So students, the question is,
2353, the number 2353, whether it is divisible by 3 or not, I wanted you to check.
sure. So we are starting to get some answers, Debapriyay sir. So Madhav says that it is divisible by 3. Shivanjali says that it's not divisible by 3. Rajiv Yadav says that it's not divisible by 3. Piyush Saini says that it's divisible by 3. Bhagyashri says that it's divisible by 3.
Yes, 2353 is not divisible by 3, because 2353, there are 4 digits involved here. So 2 plus 3 is equal to 5, and then 5 plus 5 is equal to 10, and then 10 plus 3 is equal to 13. So 13 is the number that I am getting after summing all the digits. And if you go through, if you remember the multiplication table of 3, 13 comes nowhere. So 13 is not divisible by 3. 3 fours are 12, and then 3 fives are 15. So 13 doesn't come in the table of 3. So since 13 is not divisible by 3, so 2353 is not divisible by 3. So not divisible by 3 is the correct answer. Now I give you another example, and I would like you to check whether the number is divisible by 9 or not. 7344. You need to check whether the number 7344 is divisible by 9 or not.
Students, the question is whether 7344 is divisible by 9 or not. You can comment in the chat box with the answer with a yes or no. Is 7344 is divisible by 9 or not? Yes, so we have started to get some answers. So Sanjay Asati says that yes, it is divisible by 9. Tanika Sharma says that it is divisible by 9. We have Sri Lakha says that it is divisible by 9.
Yes, correct. So 7344 is indeed divisible by 9, because if I sum the digits of 7344, what I will get is 18. 7 plus 3 is 10 and 4 plus 4 is 8. So 7344, some of the digits give me 18, and 18 is divisible by 2. So that means 7344 is also divisible by 2. So these are the things that you need to remember. Now I will go to the next slide. So how do you check whether a number is divisible by 4 or not? So you are given a huge number. So whether you need to check, uh, you require to check whether the number is divisible by 4 or not. So why you need to check? Why you might require to check whether a number is divisible by 4 or not? Because while you are doing prime factorizations, uh, in order to do it quickly, you can start with 2, because you have got an even number. So you started with 2, and then you found out that after dividing you got another even number. So you now understand that you should divide it by 2 again to get the next lower number. But if you can see through quickly by looking into the number whether the number is divisible by 4 or not, then automatically you can jump one step by dividing the original number by 4, because that saves one computation. How? Because the original number you will start dividing by 2, then you got another even number, you will again divide it by 2 to find out the next lower number. So that's basically doing 2 divisions. But if you can quickly identify whether a integer is divisible by 4 or not, then you can directly divide it by 4 and can get to the lower result in one step. And automatically, you know, in 4 there are two 2's. 2 square is equal to 4. 2 into 2 is equal to 4. So this is how you can save computation. This is how you can save time. So you need to know this result. So how? So what I do, irrespective of whatever number you are given, you just take out the last 2 digits and form a new number and form the number. So that means you rub up all the digits which are at the first, or which are in the beginning, in beginning positions, like from hundreds to other higher order positions, and just keep only the tens digit and units digit. And if you see this 2-digit number is divisible by 4, then that means the whole number is divisible by 4, and it is worth dividing it by 4 to start with. You don't need to go by dividing it with 2 first and then again getting another even number to divide it again with 2. So now in this case, the example that is given here, 1344, so it's 1344. Just think of that there is no 13, so you have only 44. So 44 is divisible by 4 because 4 11s are 44. So since 44 is divisible by 4, that means 1344 is also divisible by 4. 78531 is the next number. It's an odd number, so there is no question of being divisible by 2 even. So you don't need to check. You don't need to even think about dividing it by 4. You can simply throw it off because it's an odd number. So this rule doesn't apply for odd number. You can very easily, obviously, reason that. Now 9008. What are the two last digits? 0 and 8. That means it's 8 basically. 0 at tens place and 8 at ones place, and there is no other digit. That means it's only 8. 8 is divisible by 4. That means 9008 is also divisible by 4. So if you are asked to do factorization of 9008, you can directly start with 4 rather than starting it with 2. Now you will go to the next slide. How do you check whether a number is divisible by 6? So a number is divisible by 6 if it is divisible by both 2 and 3. Now whether a number is divisible by 2, it is easy to check. It has to be an even number. And in order to be an even number, the unit digit place should be any one of 0, 2, 4, 6, and 8. So just by looking, you can see that. And then for checking divisibility by 3, you have to sum the digits, and then you have to figure out whether the number is divisible by 3 or not. For example, 1344, it's an even number because 4 is at ones place. And if I take sum of all the digits, then it becomes 1 plus 3 plus 4 plus 4, that is 12. 12 is divisible by 3, that means 1344 is divisible by 3. That means 1344 is divisible by both 2 and 3. And that means 1344 is divisible by 6. So you can start directly dividing it by 6 to find out quickly the prime factorizations of 1344. Now I will come to the next slide. Yeah, so it is basically the rule for finding out whether a number is divisible by the prime number 7 or not. So this is the rule. So what we'll have to do, this is bit trickier and you have to remember it in order to be able to apply this. So you have to take out the last digit, or you have to take out the digit written in the ones place, and you have to double the digit. You have to double that digit. And what you have to do, you have to erase the units digit place to have a new number. The new number thus formed, you have to subtract double the digit that found out earlier, means double the unit digit place. You have to subtract that number from that new number. And if that new number is divisible by 7, then that means the original number is divisible by 7 too. For example, in case of 3357, so you have taken out 7 because 7 is at the ones place. So you will double that digit. So 7 into 2 is equal to 14. So you have got 14. Now you rub 7 out of 3357. So your new number is 35 because 7 has been omitted. Now 35, from 35 you have to subtract 14, the 14 that you have got by doubling 7. So what you have got is 21. 35 minus 14 is 21. Now this 21 is divisible by 7. That means 357 is also divisible by 7. What about 462? We will do it in a similar way. So ones digit at ones digit, it is 2. So we will do twice of it. So 2 into 2 is equal to 4. Remember that 4. Now rub 2 from 462. So you have got 46. Now from 46, you subtract 4. You got 42. Now 42 is divisible by 7 because 7 6 are 42. So that means 462 is also divisible by 42. Now I would like you to check whether 917 is divisible by 7 or not. (917) is divisible by 7 or not. I want you to check.
Yes, students. So I repeat the question. So the question is whether 917 is divisible by 7 or not. Is 917 as a number is divisible by 7 or not? You can write in your answer into a comment box with a yes or no. Let's just wait for some answers to come in the chat box. Yes, so Sanjay Asati says that yes, it is divisible by 7. Shruti Krishna says that it is divisible by 7. Kanika Sharma says that it's not divisible by 7. We have Pramod Pawar saying that it's not divisible by 7, but a lot of students are saying that it is divisible by 7.
Yeah, correct. It is divisible by 7. It is divisible by 7. Now, if you are given a large number, say for example, 4-digit or 5-digit number, then the number you might have got by subtracting the way we have done it here, 35 minus 14 equal to 21. 21 I have got here, which is very easy to check that 21 is divisible by 7. So that's how we infer that 357 is also divisible by 7. But in case the number that you are given is a big number, say for example, a 4-digit number or a 5-digit number, then probably you will get a 3-digit or 4-digit number at this stage. So you might not be able to figure it out automatically whether it is divisible by 7, because if the number is a big one, that doesn't you cannot just apply simple multiplication tables to find out whether it's divisible by 7 or not. So in that case, what you are required to do, the number that you have obtained at this stage, you have to again apply this rule to find out whether that is divisible by 7 or not. That means you have to successively reduce this difference, and then you have to come to the conclusion whether the original number is divisible by 7 or not. So let me give you one example. So let's take the example of 9184. 9184, whether it is divisible by 7 or not. How do you check it? 9184. So let me just help you understand. So at ones place you have 4. 9184 is the number. At ones place you have 4. So you double that digit. So that is your 8. So now you rub off 4, you get 918. And from 918, you subtract 8, double the digit 4. So what I have is 910. Now 910, I may not be able to easily relate whether 910 is divisible by 7 or not, because I might not have remembered the table for 13, though it's easy in this case because 13 sevens are 91. But say for example, I have forgot the table of 7 and I have forgot the table of 13 as well. So I don't know whether 910 is divisible by 7 or not. So what should I do now? So what will I will do basically, again you see that 0 is at the ones digit, so I double it, so it becomes 0 again. But I subtract or I rub 0 from 910, and then what I do, I subtract 0 from 91, so that becomes my 91. So I have got a 2-digit number. Now this 2-digit number, I need to check whether it is divisible by 7 or not. But as I have already told you that I have forgot the table of 7 and I have forgot the table of 13. So I don't know whether 91 is divisible by 7 or not. And I don't want to divide even. So I choose to apply the logic again. So I have 1 at the ones place. So I double it. So I get 2. Then from 91, I cross off 1. So I have 9. And I subtract 2 from 9. Because in 91, I have 1 at the ones place and I have doubled it. So I have to now subtract 2 from 9. So what I've got is 7. Now I can easily see that 7 is divisible by 7. So since 7 is divisible by 7, whatever number we have encountered in the path from 9184 to 7. So in the path we have obtained few other numbers as well. All the numbers are divisible by 7. That means 91 is also divisible by 7. 910 is also divisible by 7. And at the same time 9184, which is the original number that you are given, is also divisible by 7. So this is the algorithm that you need to follow in order to figure out whether a particular number is divisible by 7 or not. You can take another example and can try it out of your own. You simply add 7 with the number 9184. So that comes out to be 9191. And you can try it out at a later point of time when you have time whether 9191 is divisible by 7 or not, and can ascertain, yes, it's indeed divisible by 7. Now, I'll go to the next slide. So this slide talks about how to find out whether a number is divisible by 8 or not. The reason why we need to be able to see it, or why we are in a advantageous position if we can quickly figure out whether a particular number is divisible by 8 or not. I have explained it when I have described it for 4. So the same thing applies here too, but the rule just simply changed, though it's a minor modification of the rule for 4. You have to take out 3 numbers in this case. In case of 4, you took out 2 numbers. In case of 8, you have to take out 3 numbers from the end. So you have to take out hundreds place, tens place, and units place digit and form a 3-digit number. And you need to check whether the 3-digit number is divisible by 8 or not. If that 3-digit number is divisible by 8, then your original number is also divisible by 8. If you have 3 zeros at the end, then you need to you don't need to do anything. You can directly say that any number which has got 3 zeros at the end are always divisible by 8. So 1000 is always divisible by 8. 2000 is always divisible by 8. So and so on. So 2103400 is always divisible by 8 because it ends with 3 zeros at the end. So this is how we need to check. So in this case, the example that has been given, it is 1344. So it's 1344. So you will take out the last 3 digits, basically 100 place, tens place, and ones place. So you get 344. Now you have to check whether these 344 is divisible by 8 or not. So one way of doing it is basically to divide it by 8. But even you can do it in a much simpler way. So 344 you have got, and you know the rule for divisibility by 4. So you see that the last 2 digits is 44, which is divisible by 4, because 44 is divisible by 4. So you can directly jump into doing dividing it by 4. So if I divide it by 4, 344, if I divide it by 4, so what I will get is basically 83. And now, since the quotient is 83, which is an odd number, so that means it will no longer be divisible by any more 2's. So that means 1344 will not be divisible by 8. It will only be divisible by 4. The similar rule applies for 56240. You take out the last 3 digits, which becomes 240. And here in this case, it's very easy to check that this is divisible by 8, because 8 3s are 24. So that means quotient is 30. So you don't need to do anything. You can readily say that 56240 is divisible by 8. So this is how you can intelligently apply divisibility of a number by different other numbers. Now I'll go to the Next slide. So that's easy. Basically checking whether a particular number is divisible by 5 or 10. So a number is divisible by 10 if you see at least 10 at the end. If you see at least 10 at the ones position, if there is no 0 at ones position, then that number is not divisible by 10. And for any number to be divisible it by 5, it has to have at least 5 or 0 at ones position. So there cannot be any other number in ones position if that number has to be divisible by 5. So these are the things that you can remember or keep it in mind in order to apply these rules readily. So this is talking about divisibility of a particular number by integers from 2 to 9, and then checking divisibility by 10 is fairly simple. Now we will see uh, two other rules basically to help you with LCM and HCF. So there is something missing in the slide. So Himanshu, you can just uh, yeah, you go to the this next slide. Yeah, there is something on top of it. The example trick one is not showing up. Yeah. So there are two conditions I am stating over here to help you identify LCM and HCF. So if X is multiple of Y or Y is multiple of X, so there are two numbers you are given. One is X and another is Y. So these two numbers you are given, so you can check whether X is a multiple of Y. That means whether X is divisible by Y or not, or Y is multiple of X. That means Y is divisible by X or not. And if it is the case, if it happens to be the case, then LCM will always be the bigger number and HCF will always be the smaller number. Just simply remember that. You don't need to do anything else. You don't need to do any computation. Say for example, in case of X equal to 9 and Y equal to 18. So 9 is one number and 18 is another number. It could be any other number. It could have been a very bigger number. Say for example, whatever number you can think about, 999, two kind of. And then you can easily see that one number is basically divisible by other. So in this case, Y is divisible by X, or 18 is divisible by 9. So since it's 9 and 18, it's very easy to see. But in case of this uh, becoming a bigger number, it is not that easy for you to quickly see through. But these, if you keep in mind these numbers, then it will be it will be easier for you. So in this case, LCM will be the bigger number, which is 18, and HCF will be the smaller number, which is 9. Now, say for example, if I now talk about 189 as Y, X equal to 9 and Y equal to 189. So you see that 189 is basically divisible by 9. In that case, LCM will be 189 and HCF will be 9. Now, if I multiply both the numbers by 2, say for example, I give you 18 and 189 into 2. So X is equal to 18 and Y is equal to 189 into 2. So what it becomes? 18 and 378. So say for example, I am giving you two numbers, 18 and 378. Is it easy for you to see? This is where these rules come handy. Because what you will try to do, you will try to factorize 18. what you will try to do, you will try to factorize 378. And then eventually you will find out HCF and LCM. But if you see that both the numbers are even, so they are divisible by 2. And you see that in X, if I take out 2 from 18, then the other factor is 9. So now you go on to see whether Y is divisible by 9 or not. And you see that yes, Y is also divisible by 9, because 738, sum of the digits is 18. So that means it is also divisible by 9. That means both the numbers are divisible by 2 and 9. So you can easily mentally check all these things and can easily directly write the answer that HCF will be 18 and LCM will be 378. So you don't need to do any computation. You don't need to do anything. You can check it mentally that the answer is 18, HCF is 18 and LCM is 378. Now, next it's trick 2, where if X and Y are co-primes means one is not multiple of the other. That means in the first case, one is multiple of the other. And in this case, the two are not multiples of the other. Then what will happen? Then LCM will be product of X and Y. And HCF will always be 1. So how do you check that? So in this case, example, if you take the example I have given here, X equal to 6 and Y is equal to 11. So 6 is an even number and Y is equal to 11. It's an odd number. It's not only odd, it's a prime number too. Now you can see that no common factor exists between 6 and 11. Since no common factor exists between 6 and 11, so you can quickly figure out that LCM is equal to 66 and HCF equal to 1. Now, this look to you fairly simple because 6 and 11 are pretty small numbers and you can easily check whether 6 and 11 are co-primes or not, or basically they are not multiple of each other or not. But even when this is not the case, this rule can be applied very easily in certain cases. Say, for example, I multiply both the numbers by 2. So I'm giving you two numbers. One is 12 and another is 22. Now both are even numbers. Both are even numbers, so you know that both of them are divisible by 2. Now, since both of them are divisible by 2, so you know that 12 is equal to 2 into 6 and 22 is equal to 2 into 11. That means after dividing 22 by 2, what you are getting is basically 11. What you are getting is basically 11, which is a prime number. That means it cannot be factorized anymore. And after dividing 12 by 2, what you are getting is basically 6. So I have a common factor, which is 2. I have a common factor, which is 2. And that is my only common factor. So 2 is my only common factor. Other than 2, I don't have any other common factor. Now forget about that 2. What you have now is 6 and 11. Now between 6 and 11, there is no common factor because they are not multiples of each other and they are co-primes. Now by applying this trick, you know that LCM of 6 and 11 is 66 and HCF is equal to 1. So since 2 is basically the highest common factor, so you now very easily know that HCF is equal to 2. Now what will be your LCM look like? Will it be 66? 66 will be the common factor LCM of 6 and 11, but you are given the numbers 12 and 22, in which there is another highest common factor, which is as 2. So you need to multiply 66 with 2 to get the LCM. So that will be your 132. So 132 will be your LCM. So this is how you can apply these tricks. And in order to apply these tricks, you have to practice time and again. You have to remember all these rules readily so that you can apply them at the right point of time. So now you have a set of exercises to try out. One or two exercises you can try out that will give you confidence. So what about the divisibility of 2307? Is it divisible by 3? Yes, it is divisible by 3. Because 2 plus 3 is 5, 5 plus 7 is equal to 12. So 12 is divisible by 3, so it is divisible by 3. What about 1890? Is it divisible by 9?
Yes, student. So is option C 1890 is divisible by 9? Yes, so Gaurav Harshal says that it's not divisible by 9. Shakti Nandan says that it's not divisible by 9.
1890 is divisible by 9, right? Because if you sum the numbers, sum the digits, then it is 1 plus 8 plus 9 plus 0. So 1 plus 8 is 9, 9 plus 9 is 18, 18 plus 0 is equal to 18. So 18 is divisible by 9. So that means 1890 is also divisible by 9. And even it's very easy to see because the first two digits, 1 and 8, is divisible by 9. And then there is 9, which is again divisible by 9. And then there is lastly, there is a 0. So you can ignore that. So 1890 is divisible by 9 is very easy to see. Even you don't need to sum the digits and find out. What about 1016, whether it is divisible by 7 or not?
Yes, students, is
Is
option F.
1016 divisible by 7?
Yes, so we've started to get some answers. So Seema Thakur says that it's yes, it is divisible by 7. Uh, Gaurav Harshal says that it's not divisible by 7. Priyanka Totkar says that it's not divisible by 7. We're getting a lot of no's. Sanjay Asati says that it's not divisible by 7.
No, it's divisible by 7 because 1016. So 6 is at your, no, sorry, 1016. It's not divisible by 7, right? It's not divisible by 7 because 6 is at the ones place. So you have to double the ones place. So that becomes 12. And then you have to just think of removing 6 from 1016 and you get the number 101. Now from 101, you subtract 12. So that gives you 89. And 89 is not divisible by 7. So 1016 is not divisible by 7, right? 1016 is not divisible by 7. Yeah, that is all that I have. That is all that I have for this session today.
Yes, while we would have loved to continue talking to Mr. Debapriyay for hours, we have really run out of time. And thank you so much, Debapriyay sir, for sharing your journey and tips on mental maths. I think the
Yeah,
session was
thank
really
you.
enlightening. I think this will go a long way to help acquire one of the most important skills, which is mental maths for thousands of students listening to you today on this session. So thank you once again on
Yeah.
behalf of all the students who joined us today for the session. We'll just quickly check if there are any questions in the comment box, in the chat box, so that we can ask you the same. So one important note, students, please do take out time to share your feedback on this masterclass. The link for the form is given in the description of this video and is also pinned as a top comment in the chat box. This will really help us to improve our masterclass for thousands of our lead students just like yourself. So please don't forget to share your feedback on the form. It's pinned as a top comment of the chat box and it's also given in the description of the video. So I think there are not any questions, sir, as we scroll through the chat box. So I think finally we have come to the end of today's session. We hope all of us will start and continue on our journeys, improving our mathematics skills by practicing what sir has taught us today. Sir, any closing thoughts and closing notes on your end?
Yeah, only closing thoughts that I have in mind is basically you need to practice a lot. Mathematics is not only just learning the skills and just remembering the skills. You should practice a lot, because only with practice you will be perfect. You will get perfection, and you will automatically figure out other avenues of thought. Because until and unless you figure out your own way of thinking, until and unless you learn to think why you should do this step, there is no one who can learn you, make you learn all the steps. Because teachers or parents can help you in guiding certain problems, in helping you to solve certain problems. That's basically the learning part of it. But through practice and through your own thoughts, you will be in a position to assimilate whatever you have learned from your teachers and parents. So this assimilation part is pretty important, and that comes only through practice and hard work. So that's the key to get success in mathematics.
Yes, so hard work and consistent practice is a key to success in mathematics, as has rightly pointed out. So finally, thank you everyone, and thank you once again, Mr. Debapriyay. We really loved enjoying learning from you today. Signing off from today's session. Goodbye and take care.